Hello, everybody. Um, since some people wanted extra credit opportunities for the course, I decided I would throw together a little bonus module where you can get up to, I believe, 5% extra credit for your final grade. And if people like this, I'll do a few more. I have some ideas for what I might do. So anyway, in this module, I'm going to cover partially some of the stuff that's in one of the chapters in Quine's book that I didn't bother to cover in my book. And so and this will also just fill in some extra info about truth functions that maybe you weren't aware of. So the chapter that I'm going to talk about for a few minutes here is the chapter on duality. And so let's just look at the truth tables for conjunction and alternation. And I ordered the assignment of truth values in a different order for a reason here. So if we take, let's look at this, if we take the truth table for conjunction, right, and we switch all of the truths, right, in every row and every column with falses, we get the truth table for alternation. See, so like this is true here, and it's false here, and this is true here, and it's false here, and this is true here, and it's false here, and so on and so forth. The way that we have a name for this relationship between alternation and conjunction, we say that they are duals of each other. And a dual of some logical operator is just the what you get if in the truth table for that logical operator you replace every true with false and every false with true. And so in this course we've been restricting ourselves to 5 truth functional operators. So we have conjunction, we have negation, we have alternation, we have the conditional, we have the biconditional, right? So if you were really paying attention to what was going on when we were converting to conjunctive normal form, we actually don't need all of these because we can rewrite conditionals and biconditionals using just conjunction, negation, and alternation. Conditionals and biconditionals are kind of superfluous. We could get rid of them if we wanted to. Our logic would be a lot harder to read and a lot harder to translate into, but it would work. And so there are, I believe, 16 possible truth functional operators. You don't usually encounter them that much in a formal logic course, but if you're a computer science or computer engineering major, you'll run into them all the time because these truth functional operators correspond to logic gates in electronics, right? And sometimes when we're designing electronics, or processors, it's useful to have different truth functional operators. And so actually, I'm not going to do too much with this, but just as a fun fact, if you are a computer science major or computer engineering, you've probably run into this truth functional operator known as NAND, or not and, right? And so the truth table for not and is it's false when both of the components are true and true otherwise. And actually, if we really hated ourselves, we could write every single schema in our logical system using only this NAND operator. But we're not going to do that. It's very useful for designing electronics for that reason, but it's really cumbersome. So instead of looking at something like NAND, or I'm not going to write the truth table, but if you've ever seen the word XOR, that's XOR, or the exclusive OR, which if you remember is another way in which we use the word OR in English. But anyway, so what we're going to do in this module is we're going to look at the dual of the conditional. There is actually a fancier name than anti-conditional for this, but I'm just going to call it anti-conditionals for now. So if we take the conditional, right, and we look at our truth table for it right here, You should all be familiar with it by this point. The dual of the conditional, so what we get if we switch all the truth values around in our truth table for the conditional is, I'm calling it the anti-conditional, which if we represent the conditional with an arrow going from the left to the right, we will represent the anti-conditional with an arrow going from the right to the left. And so we have truth value analysis rules for our conditional that should make some sense if you look at the truth table. So our truth value analysis rules for the conditional, the first one is drop true as the antecedent of a conditional, right? The second one is reduce a conditional with a false antecedent or a true consequent to true, right? The third one is drop false as consequent of a conditional and reduce the hold and the negation of the other side. Okay, and look at the relation between those rules and the truth table just for a second. I didn't hammer home when I was explaining it how these rules are derived from the truth tables, but I think if you study that, it'll make sense as to why we have those rules. So for this anti-conditional, we can come up with reduction rules as well. And so for 1% extra credit for your course grade for each of these, I would like you to come up with the reduction rules that we would have to use in truth value analysis for the anti-conditional. And we need 3 of them, I'm pretty sure. I will give you a mountain of bonus points if I'm wrong about that, and you can come up with 2 rules. You can't just conjoin 2 rules and call it 1 rule, though. They have to be 3 different rules. They'll look somewhat similar to the rules for the conditional, and one convention to make writing these easier is we're going to say that anti-conditionals have antecedents and consequence just like conditionals do. So in the anti-conditional, I don't know what to read the arrow as. P here is going to be the antecedent and Q is the consequent. Right? So again, 1% extra credit for your course grade. Give me the 3 reduction rules for the anti-conditional. Okay? So once you've done that, then I want you to use those rules to tell me which of the following schemata are. I always mix up the plurality of schemata. I'm sorry about that. So which of the following schemata sorry, no, oops, I wasn't reading. I was correcting myself and I had it right. I guess which one, because there's only one unless I've screwed something up horribly. Which one of the following schemata is equivalent to this schema using an anti-conditional? And so what you have to do to get these bonus points is you need to give me 3 different truth value analyses where you use the rules that you made up here to test for equivalence. Right? And if you do that correctly, if you do everything right here, I'll give you 2% extra credit on your final grade for the class. I'm not going to go into too much detail about how you would do this because part of the point of this is for you to think and figure it out. But I don't think it'll be too bad if you sit down and spend some time on it. So remember, you have to submit the truth value analysis that uses those rules, and they have to be correct. And if you would like to attempt this for extra credit, take a picture of your work, and you have to show all your work, and email it to me. Don't submit it on Canvas. Yeah, so give that a shot. And I have a few other ideas for little extra credit opportunities like this. And yeah, hopefully this isn't too bad and it's kind of an easy option to get you some bonus points if you need them.